So thank you everyone for joining us today. My name is Jenny Chase, and I am the Vice President of Workforce Development for the National Glass Association. And I am joined today by our special guest, Mr. John Griggs. John is Manager of Field Service Engineering North America for Guardian Industries, and he was a part of the development of our new tempering technician certificate training. So thank you, John, for joining us, and thank you everyone for taking the time to participate in this webinar today. I'm excited to dive into today's topic, but before we do, I have a couple of quick housekeeping notes. First, today's session will be recorded, and we will post it on glass.org afterwards. We do have the chat functionality working, so if you have any questions throughout the presentation, please feel free to pop them in there, and we'll have time for Q&A at the end. And we'll also be sharing links in the chat, so please keep an eye out for those. If you aren't aware yet, later this summer, NGA is introducing a new event for glass fabricators, GFAB, the NGA Glass Fabricator Conference. GFAB combines the strengths of NGA's previous events, so it's a combination of the NGA Glass Conference, where NGA committees gather to discuss technical and advocacy topics, and the former GPAD, Glass Processing Automation Days, where fabricators gathered for education on improving efficiencies, productivity, quality control, and things of that nature. So this new event will be in Chicago, June 14 to 16. And in addition to an executive track and a technical track, it's going to feature a workshop. And this workshop is going to be focusing on quality control. So a lot of the topics that we cover in the tempering technician certification program will also be covered in this hands-on workshop on tempering. So I would encourage you to check it out. All right, so moving on to our primary topic, the Tempering Technician Certificate Program. So NGA recently surveyed glass fabricators on LinkedIn and asked them what their biggest quality control issue on the tempering line was. The top answer was operator error or training gaps. And this is something that we hear consistently from fabricators. The people running your tempering lines, they're doing their best, but they may not have had access to structured, standardized training on the full heat treatment process. So John, this was something we discussed a lot within the task group when we were developing this training. From your perspective as a fabricator and tempering expert who helped to create this tempering technician program, can you talk a little bit about why you feel this type of training is necessary and important?
Yeah, thanks, Jenny. First of all, thanks for having me, and I appreciate everybody that's attending this meeting. I already see a few familiar or names on the attendee list, so that's always good to see. So, for those that aren't familiar, I've one of the things that my group does is we provide a lot of support with like tempering and processing along those lines. So. Over the years, what I've found, I've provided quite a few presentations in the classroom setting and hands-on training at the fabricator level. And you'd be surprised how often people that handle a process or run a piece of equipment on a daily basis, how little they actually know about it. It becomes, in some cases, they put it in one end and it comes out the other. And they might know a little bit on some adjustments, but they don't understand why they do what they're doing, which why is the highest form of knowledge, right? So this type of training, in my opinion, really provides some knowledge that can build confidence and people can make connections to really impact anything from throughput to quality, what quality QC is required, why it's important, things of that nature. Many fabricators don't have a formal training program at all, and even if they do, it's internally developed, and creates an opportunity for variability and inaccuracies, right? So if a fabricator doesn't have a formal training program, they become reliant on guess and check, or what I call tribal knowledge, right? So if with that tribal knowledge, it becomes voodoo. What I tell people, tempering isn't voodoo. There's science behind it. But it creates a lot of opportunities for misinterpretations. What's actually happening, and it can without that base knowledge, you can create a situation where your quality can struggle, or you have extreme swings in throughput, or even the end product, bow, warp, distortion, everything. So
thank you, John. Appreciate your input there.
mm-hmm.
So next slide, as John described, it's for these reasons that NGA developed the Tempering Technician Certificate Program. And critically, it was developed by the tempering experts on NGA's fabricating committee. So this isn't generic manufacturing content. It's really specific to our industry. It's built by people who understand your equipment and your production environment. So just wanted to take a moment to recognize and give a shout out to everyone here on screen who helped to build this training. So moving on, what is the training and who is it for? The Tempering Technician Certificate Program is a 6-course online training program built specifically for tempering personnel. It walks your team step by step through the entire heat treatment process from start to finish, with a focus on the tasks and best practices that drive high product quality. So it's very specific to what personnel are doing on a day-to-day basis. It's designed for everyone working in your tempering department, whether that's the furnace operators, your quality control personnel, your production supervisors, and it covers 6 areas. The basics of heat treating glass. This is where they learn the different types of glass, the difference between tempered and heat strengthened, how to prepare equipment for heat treating, how to repair the glass for heat treating, how to operate the furnace, how to read the glass and adjust the furnace settings accordingly, how to inspect heat treated glass, and how to maintain the equipment itself. So all of these courses live on the MyGlassClass.com site. And I'm going to take a minute to share my screen and give you a little bit of a walkthrough. So to find them, you're going to the MyGlassClass.com site, going to the course catalog, and it's always when you do these demos that your internet is a little bit slow. And here you'll see right at the top, our feature learning is this new program. You'll notice that we have the tempering training in both English and Spanish. And the training is broken down into these 6 courses. And if you click here, you can see each of the things that personnel will learn. And you can also watch a preview of each course to give you a better idea of what this training is. So I'd like to show you one of those videos to give you a quick snippet from the How to Prepare Glass for Heat Treatment course that talks about arranging batches on the load table. So you can get a taste for the type of training we are offering.
When production glass enters the cooling section of the heat treating furnace called the quench, it rides on Kevlar-wrapped rollers. This lesson focuses on inspecting these cooling rollers and their belts for signs of damage. When the furnace is finally turned on, make sure all rollers in the cooling and quench sections are spinning. This might seem like a simple step, but it's very important to check that everything is working the way it should. To do this right, it helps to know what the rollers are made of. The shaft. This is the center part of the roller, usually made of strong steel. The Kevlar wrap. Kevlar rope is wrapped around the shaft. It can handle high heat and helps move the glass without scratching it. The bearings. These are at both ends of the shaft and help the rollers spin smoothly. The drive belt or drive chain. This belt or chain moves power from the motor to the rollers, helping them turn. During the roller check, there are a few things to watch for. We'll go over those next. For the rollers to spin correctly, the bearings must also be working well. When a bearing gets stuck, it won't let the roller turn like it should. Here are some things to watch for when checking the bearings. If a bearing is loose or stuck, the roller might shake or vibrate. If you hear a loud squealing sound, that could mean the bearing is starting to fail. Bearings work within very high temperatures, which means the lubricant can be dried up by the heat, creating the squeal. Bearings can also smell like they're burning before they fail. Just like bearings, drive belts and chains can wear out over time. Belts are made of rubber and can wear out as they get older. When that happens, they can become too loose and won't turn the rollers properly. The quench section is usually chain-driven, and the chain can stretch or wear over time, becoming loose or fail to make proper contact with the quench roll sprocket. Check for proper tension and that all the quench rolls are turning.
So that's an example of, and actually that was from our How to Prepare Equipment for Heat Treatment course, my apologies, but that's an example of the type of information that we're covering in these courses. One of the other topics that the task group spent a lot of time on was the tempering process itself. John referred to it, tempering is not voodoo, but as you all know, it's also not an exact science. And furnace operators need to learn how to read the glass and interpret what it's telling them. So the group tackled this topic in the How to Operate a Heat Treatment Furnace course, and you can see the topics that are covered within that course. And it really gets into how to control the heat distribution in the furnace, how to read the glass, how to make adjustments accordingly. And I'd like to give you a quick preview of that course as well to show you what you can expect.
As a furnace operator, you are responsible for not only preparing the glass and equipment, but also for the heat treatment process itself. This means monitoring the glass as it enters the furnace during the heating phase and the quench phase, recognizing problems with the glass when they occur, and adjusting the furnace settings to correct those problems and ensure the glass meets quality standards. As you take this course, keep in mind there is no one-size-fits-all way to heat treat glass. Every decision a furnace operator makes, from loading to recipe selection to settings, affects the glass. This course focuses on the best practices for operating a furnace to produce quality heat-treated glass. Upon completion of this course, you will be able to discuss how to control the heat settings of the furnace, describe how to control the cooling settings of the furnace, discuss furnace parameter effects on the glass product, troubleshoot furnace equipment and settings related to product results, take correct actions during an emergency. This course will take about 30 minutes to complete. There are a number of recipe settings that affect how the glass is heated in the furnace. As an operator, you need to know what these are and how to adjust them in response to how the glass behaves. Click each button for more information. The soak temperature is the target internal temperature the glass needs to hit for proper tempering or heat strengthening, usually around 610 to 640 degrees Celsius, 1130 to 1184 degrees Fahrenheit. The furnace itself usually runs a bit hotter than that to make sure the inside of the glass gets up to temperature. top zone temperature refers to the settings for the top heating elements in the furnace. These settings can usually be adjusted separately across different zones, either across the width or down the length of the furnace. Being able to fine-tune these zones gives you better control over how evenly the glass surface heats up. It's especially helpful for fixing problems like downward bowing or uneven temperature between the edges and center of the glass. Bottom zone temperature is the setting for the heaters underneath the glass. These are usually set a bit lower than the top heaters because the bottom of the glass also gets heat from touching the furnace rollers. That extra heat from conduction needs to be factored in to keep things balanced. Temperature profiling is all about adjusting how much power each heating zone gets, like dialing in more heat to the center compared to the edges. Since the edges tend to heat up faster, adding a bit more heat to the center helps even things out and cuts down on distortion issues like edge kink. Convection power, or intensity, controls how strong the hot air gets blown onto the glass surfaces. This helps boost heat transfer, especially for low E glass, which tends to reflect radiant heat and can be harder to heat up evenly. Convection timing, or pulse mode, lets you control when and how often the hot air gets blown onto the glass. It can run constantly, in short bursts or only in certain zones. The goal is to keep the heating as even as possible across the glass. Ramp rate is basically how quickly the furnace heats up. If it heats too fast, you risk thermal shock and the glass can break. Too slow, and you're just slowing down production. The sweet spot is a steady, controlled ramp that brings the glass up to soak temperature gradually. Soak time is how long the glass stays in the furnace after it hits the soak temperature. Oscillation speed is how fast the glass moves inside the heat chamber. This helps cut down on roller wave distortion. As the glass gets thicker, you usually slow down the oscillation or even reduce the time it's used. A continuous furnace does not have an oscillation function. Cycle rest, or dwell time, is the break between unloading one batch of glass and loading the next. It gives the furnace and the ceramic rollers a chance to bounce back and stabilize their temperature before the next round starts. Operators need to keep an eye on how the glass is behaving and how the furnace is performing temperature-wise. You do this at both the start and end of the furnace cycle. First, right when the cycle starts, open the furnace door and take a close look at the glass as it goes in. Note, only do this if it's part of your company's standard procedure and you're following all safety rules. Then, at the end of the cycle, watch the glass as it comes out. Check its color and the temperature reading from the pyrometer, which is the furnace thermometer, to make sure everything's on track. The pyrometer target temperature usually falls between 610 to 640 degrees Celsius, depending on glass type. If the temperature's too low, the glass might break during quenching because it's underheated. In that case, try bumping up the recipe temperature, soak time, or the cycle rest dwell time. If it's too high, the glass can get distorted or show issues like roller wave distortion or pitting. Then you'll want to cut back on soak time or lower the zone temperatures. Note, keep in mind that low E coatings can make the pyrometer give a false low reading. When you're watching the glass enter the furnace, check to make sure the glass rides flat across the rollers. If the glass starts bowing right away, it means the heating isn't balanced. Just adjust the zone settings to fix it. Watch the glass exit. Look at color, glow, and motion of the glass. A lack of a red glow may indicate the glass temperature is too cold. Different glass types and thicknesses may also influence the level of the red glow. If you see the glass pulsing or bouncing, that usually means there's a mechanical problem, like rollers that aren't lined up right, rollers that aren't wrapped properly, or conveyor speeds that don't match up. Use feedback from zebra board or inline distortion system. Too much roller wave distortion usually means the furnace is running too hot or the glass is at soak temperature for too long. If you're seeing a lot of edge kink, it might be because the heat profile isn't right. Too much heat is hitting the edges compared to the center. As the glass moves through the furnace, it may show bowing, distortion, or blemishes. Click each button to learn how to adjust the furnace settings to correct these conditions. Bow up is when the edges of the glass bow upward, kind of like it's forming a shallow bowl. If you poured water on it, it would actually hold it. People sometimes call this type of bow smiling. If the glass is bowing upward, it usually means the bottom is heating up too quickly. You can fix it by turning down the bottom heat zone or bumping up the top heat. You might also need to increase the top convection or dial back the bottom convection. This kind of issue often shows up when the glass has that skunk stripe.
So that's another example of one of the courses that we offer. So each of these courses comes with a preview that you can watch and a list of all of the tasks that personnel will be trained on. So I would encourage you to go to this page and take a look, watch the previews, so you can better understand the content of these courses. John, as a member of this task group, is there anything else you'd like to share with everyone about what you think makes this training unique?
Yeah. So from my perspective, this is a good balance for an introduction to the heat treating. And these are great modules for a broad group of people, operators, obviously, but even new supervisors or managers in the heat treating department or who aren't familiar with it. This is a great introduction to that, and even maintenance technicians. So, the content isn't so technical that it's over top of people's heads. It's meant to be consumable. So the concepts are coherent and digestible for everybody. And the great visual, so people you don't just have somebody talking at you. You can see exactly what some of the videos do a really nice job of showing the process. And then finally, it's operated at their own pace, so they can. Jenny was moving pretty quick there, but they could stop, think about it, digest, and move on. So I think the team from NGA did a really nice job of making this digestible and coherent and a really good process flow. So that's kind of why I think this is somewhat unique as compared to what's out there on the market.
Thank you, John. So getting into the nitty gritty and building on what John was saying, again, everything is available in English and Spanish. To get through all of these courses, it's about 3.5 hours total of training. But each of these segments, so if you look on screen, you'll see each of these bullet points. These are all individual lessons. And each of these lessons is anywhere from 5 to 10 minutes long. So you don't have to sit down on your phone or your computer for 30 minutes and take a course. You certainly can. But you can also do it as John was referring to, at your own pace. So you can take a 5-minute course on maintaining the load and unload tables, a 5-minute course on the rollers, etc., etc. We broke these courses down this way very intentionally because after personnel finish that training, they still have access to all of this and they can quickly go back and reference it when performing certain tasks. So, for example, if they take the training how to inspect heat treated glass and they are specifically looking at how to measure bow, when it's time to actually do that measurement, they can go right back to that lesson specifically. It's like a 5-10 minute lesson to remind themselves of the correct procedure. So it's not just a one-time training, it's something that they can use as a support tool on the floor as well. And they can do that because these courses are available not just on their phones, not just on their computers, but also on their phones, so they can reference it pretty quickly. All right, I'm going to stop my share. Sarah, if you don't mind going back to the PowerPoint, that would be great. So within each lesson and at the end of each course, there are quizzes that employees must pass. And if they complete all of the training and pass all of the tests, they earn the NGA Tempering Technician Certificate of Achievement. They also receive a badge that they can use wherever they'd like, whether it's on their social media, internally, what have you. So the title of this webinar was Stop Losing Money on the Tempering Line, and that was very intentional because I want to take a moment to connect this training to your bottom line. When we surveyed our top glass fabricators for Glass Magazine this year, 97% said that they offered tempered glass, so it's their core product. And to make that product, you're investing in tempering equipment that runs anywhere from $150,000 to well over $1 million, depending on whether you're doing a single furnace, it's used, it's new, or you're building out an entire line. So you're already committed financially in terms of product mix and equipment. But when your most important product is being made on your most expensive equipment, my question is, what happens when the people running it aren't fully trained, right? So I can't tell you what your costs are when it comes to rework. We don't have any fabricator specific statistics on that yet. But in our initial survey of fabricators, which we referenced in the beginning, 50% of fabricators said that their biggest quality control issue on the tempering line was operator error or training gaps. So I would encourage you to look at your rework stats and what they may be costing you if you don't have a consistent training program in place. What I can tell you, if we move to the next slide, is what the research shows when you do invest in training. So organizations with comprehensive training programs generate 218% higher revenue per employee, and that's from the American Society for Training and Development. The National Institute of Standards and Technology, which is a government organization, found that structured work instructions, which is what this training offers, reduce manufacturing errors by 40%. And in a Manufacturing Institute survey, which is the National Association of Manufacturers Workforce Development arm, nearly 75% of manufacturers who implemented structured training reported increased productivity. And if you look at the bottom, I found this statistic particularly interesting. It's a study by the National Center on the Educational Quality of the Workforce, and they found that a 10% increase in workforce education produces an 8.6% productivity gain. So again, look at what you've invested in your product mix and your capital equipment, look at your rework costs, and look at what a potential 8-10% productivity gain could add to your bottom line if you invest in training employees. So we've designed this program to be as easy and straightforward as possible. If we move to the next slide, I can talk to you about getting enrolled. It's pretty straightforward. You can go directly to myglassclass.com, as I showed you. Individual enrollment is available at $299 per learner, and we do offer multi-seat discounts for teams. So if you have a team of 4, 8, what have you, your pricing goes down per learner the more seats you purchase. We do have non-member pricing. So if you're not yet an NGA member, I'd encourage you to reach out to us about membership because the savings do add up pretty quickly. If you would like to preview the program before enrolling your team, take a note of this email address on screen. We can provide you with a free 7-day trial so you can actually go through the training itself and see how it would fit within your organization. So with that, are there any questions that John and I can answer? Or did I answer everything that you all need to know? I see one question. Is it already translated to Spanish like other courses? Yes. So everything is available in Spanish. So people will see everything that you saw on screen translated to Spanish, audio, visual, videos, everything available in Spanish already. Any other questions that I can answer? I love questions, but I also feel like if there aren't any, then maybe we've answered them already. So, high five on that, John. Sarah, any that came in for you?
Nope, you've addressed them as well, Jenny.
Perfect. All right, so I just want to thank you all for spending time with us today. I hope this gave you a clearer picture of the type of training that we're offering, and what it can do for your operation. Again, if you are interested in either our multi-seat discounts or in getting a preview of the training, please reach out to us at myglassclass@glass.org. And just a reminder that the GFAB conference is coming up very quickly, and we do have that special workshop track on quality control in glass tempering, and seats are limited. So if that's something that you're interested in, please go to glass.org and check it out now to make sure you get your seat. So I hope to see you all in Chicago, and I hope to hear from you soon. And thank you for your time. Have a great day.